Hello, good morning. I hope you had a wonderful night's rest. Welcome again and thank you for having me in today's class. It is obvious we are making a progress. I'm so proud of you people. Your performance in the last assignment was wow. I'm so happy. So let's keep on making progress. If you are just seeing this video for the first time, know that um, I have an online coaching class 100% free. I have students I'm coaching, I'm training to see that they emerged among the top in the JAMB this year 2025. If you would like to join the class, it's for free. You can drop a comment on the comment section. I will see how I will link you up to the class, and we will journey together. And if you are my student and you are coming back, I hope you have been participating well. How was yesterday's challenge? I'm so happy with you people. You are trying, you are doing well. So you keep improving gradually, and before you know it, by the time jump comes, don't worry. I'm happy with your performance. That's You guys are making me proud. So thank you so much. One favor you will only do for me is to keep on following. We will get there. So thank you so much once again. So um, today we'll be looking at some questions in physics that are also critical, that have appeared in the JAMB in previous years, and I feel it is necessary we should also touch these areas because they keep coming up every year. It might not be exactly the same, but with a little changes. You see how yesterday's challenge was. I just twisted some questions, but I'm glad that you people were also able to decode it. That's how Jam said their questions. You see that just little changes, from negative to positive, I just changed a few things. That's it. They don't need to set questions every year. They don't need to. They already have enough questions. So all they need to do is just look at last year questions, pick some, make some changes, and that's it. So that's what I did yesterday. So I was trying to show you the format. Yes, I want to show you the tricks. That's why my course is different. It's not like every other person. Sincerely, what I'm giving you can't get it anywhere. I bet you. You can try it. Try it. All right, so let's quickly go into today's business. So we are looking at physics today. And I've categorized the questions based on topics. And the first topic we have here is under mechanics. So let's look at the first question right away. So the first question says, a stone and a feather dropped from the same height above the Earth's surface, ignoring air resistance, that is to say, assuming there is no air. Which of the following is correct? A. The stone and feather will both reach the ground at the same time. B. The stone will reach the ground first. C. The feather will reach the ground first. Alright, D. The feather will be blown away by the wind while the stone will drop steadily. You guys have already seen my answer. Alright. So the correct answer is A. The stone and the feather will both reach the ground at the same time. Yeah, this question is a little bit confusing if you don't really understand physics and gravitational force. So when there is no air, there is no air resistance. the amount of gravitational force acting on two objects, regardless of their mass, regardless of how big this one is small. No, the gravitational force acting on both the objects is the same. So they will fall at the same time. So if air resistance is not there, if air is removed, assuming there is no air to stop the feather from falling, both the air and the feather will fall down at the same time. This has been tested several times and you can try it. If you can create such an environment, you can try it. They will fall at the same time. So please note that. I know many people will say the feather will reach the ground first. That's the wrong answer. As a science student, you need to know this. So the stone and the feather will reach the ground at the same time. Okay, let's go to the next question. All right, I've written a little explanation there where I say in the absence of air resistance, all objects fall at the same acceleration due to gravity. Yeah, I've explained that already. So let's look at the next question. Before I go, this just came to my mind. There was a question I came across that says 1 kg, 1 kilogram of water is heavier than 1 kilogram of feather. 1 kilogram of water is heavier than 1 kilogram of feather. True or false? What's the answer? Alright, don't worry, I'm giving you some questions for mental drill for those of you who are smart. Alright, so their weight is the same. Their weight is the same. 1 kilogram of water is never heavier than 1 kilogram of feather. You may have to have a lot of feather before you can get 1 kilo, but their weight with that of 1 kilo of water are the same. Please note this. These are somehow tricky questions that may require you to think. But as a science student, I believe these are even simple stuff. So, the first thing that will come to mind is that a feather is lighter now. It's not heavy. But you have to be careful. Get the question clearly. Thank you. Let's go to the next question right away. So the next question says, a car moves with an initial velocity of 25 meters per second square per second and reaches a velocity of 45 meters per second in 10 seconds. What is the acceleration of the car? Now, you need to know the formula for acceleration before you can answer this question. And the formula for acceleration is final velocity minus initial velocity all over time. That is, A is equal to V minus U all over T. This formula is very important and I hope you memorize it. Very important. You can use it to calculate initial velocity, you can use it to calculate final velocity, you can use it to calculate time, you can use it to calculate acceleration. So in this question now, we are given initial velocity, that's our U, as 25, and we are given our final velocity, that's V, which is 45, and time is given, which is T. So if we now say final velocity minus initial velocity all over time is going to be 45 meters per second all over, minus 25 meters per second all over 10. So by the time you say 45 minus 25, you will have 20 over 10. So 20 divided by 10, that will give us what? 2 meters per second square. So the correct answer is D. I wrote A. I wrote A. Please, it's D. Thank you. Not that is D. Is D. Yeah, my calculation is showing 2, but I mistakenly wrote A. Alright, please, the correct answer there is D. So let's go to the next question. Next questions are under heat and thermodynamics. So our question here says, yes, what happens when a certain quantity of pure ice is completely changed to water at 0 degrees Celsius? Now, you have to develop this skill of attention to detail. Attention to detail, very important. If you are not attentive to detail, there is problem. You omit some things, and that will be very, 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 very bad. Look at this now. What happens when a certain quantity of pure ice is completely changed to water at 0 degrees Celsius? Do you see these two parameters? Pure ice, 0 degrees Celsius, very important. So what happens? Let's see. A, latent heat is absorbed, the mass decreases and the volume increases. B, latent heat is absorbed, the mass remains constant and the volume decreases. C, latent heat is given out, the mass increases and the volume remains constant. Lastly, D, latent heat is given out, the mass remains constant and the volume decreases. Alright, so if I bring out an ice block from a fridge and keep it at 0 degrees Celsius, and that ice block melts at that temperature, no heat was applied on it. So what happens? So for the ice block to change to water, it means the intermolecular forces have been broken. The force that brought the water molecules to be packed together into ice, they have to be broken, those forces. And for those forces to be broken, energy is required. So which means there is an absorbance of latent heat. So the correct answer being B, the latent heat is absorbed, the mass decreases. No, sorry, the mass remains constant. The mass cannot decrease. If the mass decreases, maybe the water has changed to vapor, and some have escaped in form of vapor. So mass doesn't decrease, please. So, but heat is absorbed to be able to break the bonds of the ice to change it into water, though at 0 degrees Celsius. The mass remains constant and the volume decreases a little. Why will the volume decrease? The volume of ice and water may differ because of the shape and also the state of the existence of water. I think I've written a little explanation here. So I said the latent heat of fusion is absorbed to break the molecular bonds, but mass remains unchanged, while volume slightly decreases due to the density difference between the ice and water. That's that. So let's go to the next question. Question 4. Question 4 is under waves and optics. Shadows and ellipses and eclipses result from the... Now we all know shadow. We see our shadows during the day, and at night when there is light we see shadows of objects. So what actually happens? What is it resulting from? What is causing it? So A, we say refraction of light. Refraction of light. What is refraction of light? Refraction of light has to do with the changes. Okay, we have refraction, reflection, and even diffraction. So all these are changes in direction of light. When light rays are moving, there can be obstacles that can lead to changes. For example, when we're talking about these three, which are very important, when light passes through a medium, let me explain this clearly so that I will get questions for drills. Yes. So when water passes from one medium into another, it changes direction when light passes from one medium to another. For example, sometimes if you put a stick in water, it will appear as if the stick bends, but it's straight. So what's happening there? As the light rays passes from air medium into water medium, it changes direction. It diffracts. So that's what we call diffraction. Reflection, we all know reflection. Reflection is when there is a direct bouncing back. The light hits an object and it bounces back, reflection. For example, if you bring a mirror under the sun, you can be able to reflect the light so that where there is darkness, if you direct that mirror towards that direction and you are directing the light rays from the sun, you will see that place that is dark with the light. So the light rays are being reflected in another direction. So then the last one we have rectilinear propagation of light, which is actually the correct answer. So for a shadow and eclipses, they are a result of rectilinear propagation of light. So when light hits an opaque object, an object that does not allow light to pass through it, so that object blocks the light. So if the object blocks the light, then we can see a shadow. Any object that cannot block the light is transparent object, so light will pass through it. Yes, and there will be no shadow or eclipses. But if the object can block the light from passing through it, if the object can block the light from passing through it, the light will cause the shadow of that object to be casted or eclipses. This is the same thing that is happening between the sun and the moon. For those of us that did geography, we know that the moon does not produce light. It reflects the light of the sun. So when the light of the sun shines on the moon, because moon is an opaque object, it reflects that light into the earth. So this is physics still, but it's also part of geography. So we should know that, please. Let's quickly go into the next question. Electricity and magnetism. So this question says, which of the following obey Ohm's law? Which of the following obey Ohm's law? Okay. So what's Ohm's law? Ohm's law is talking about voltage and resistance, that they are directly proportional, provided that current is constant. So the law is stated as V is equal to IR, and the current is the constant parameter there. So but the question is asking us, which of the following obey Ohm's law? Ohm's law, we all know, is talking about electricity. So diodes, electrolytes, and glass. Glass does not even conduct electricity, so it's already out. Electrolytes, we know electrolytes, right? They are liquid substances. This is one of the mental drill questions, so very interesting. So they are liquid substances that conduct electricity. This is what we call electrolytes, like sodium hydroxide, sodium chloride, hydrochloric acid. Almost all the strong acids, they conduct electricity because they ionize in water, and bases too. So diodes have semiconductors, are made of semiconductors, so they may not obey Ohm's law They cannot even obey. So the correct answer is A, which is all metals. All metals conduct electricity. All metals conduct electricity. All right. Okay, this came to mind. Let me say it. All metals are solid except one. Now, they may be soft. Some may even be semi-solid, but they are categorized as solid. But we have one that is liquid. Do you know it? Mercury, correct. Mercury is a metal, but it exists in liquid form. It's the only metal that is liquid. I remember also saying in one of my classes that fluorine is the most reactive element on Earth. Silver is the element, is the, silver is the metal with high electric conductivity. I have also said this, where I asked, why is it that we are not using silver cables to transmit electricity? And I answered the question. I say it is expensive, it is difficult to get, and it's heavy. So if you place it on poles, poles will just be falling every day because of the weight. So that's why aluminium is being used instead. Aluminium is cheap, easy to get, and it's light. So electricity is transmitted mostly through aluminium cables. So these are some small things here and there that are good, and you may be surprised to see them. All right, so next is question 6, which says, if two parallel conductors carry current flowing in the same direction, the conductors will A, repel each other, B, attract each other, C, both move in the same direction, and D, have no effect on each other. So the correct answer is B. According to Ampere's law, if current is flowing in the same direction, it causes magnetic field, thereby bringing the two cables together, attracting each other. So that's the correct answer. Don't forget the basic law of electricity that says like charges attract, no, like charges repel, unlike charges attract. Please and please don't forget this. Unlike charges attract, like charges repel. This is also physics. Alright, so I've explained the reason why attraction occurs, because a magnetic field is produced, and so there can be an attraction. Alright, so let's look at the last question. The last question says, a piece of radioactive material contains 1000 atoms. If its half-life is 20 seconds, the time taken for 125 atoms to remain is, now this is radioactive element. At your own time, you can study radioactivity, radioactive elements, radioactive decay, and applications. Most importantly, applications, the applications of radioactive elements in the generation of electricity, in medicine, in agriculture, in different areas. So you can do that. But let's look at this. Now, when we are talking about radioactive decay, because here that's what is happening, radioactive decay, it means that if I have 1 kilo of uranium, if its half-life is 20 seconds, after 20 seconds, that half kilo will change to 0.5 kilo. And that 0.5 kilo, after 20 next seconds, it will change to 0.25 kilo. That means it will be reducing after every half-life. So now we have 1000. How many seconds will it take for it to reduce to 125? All right, so the calculation is here under explanation. So let's look at it. In one half-life, the quantity halves, that is, the quantity reduces to half. So let's now see from 1000, the first half-life, the quantity will change to 500. The second half-life, the quantity will change to 250. That's after first 20 seconds, it will move from 1000 to 500. After second 20 seconds, it will move from 500 to 250. After third 20 seconds, it will move from 250 to 125. Are you following this? So in 3 half-lives, that's 3 times 20 seconds. In 3 half-lives, we will get it reduced to 125. And in each half-life is 20 seconds. So 20 times 3, that will give us 60 seconds. So we've come to the end of today's class. Thank you so much. Do your assignment. See you in the class. Thank you and bye. Have a great day.